All right, so Mr. Robs here, we're given this particular function f of x, 2 plus 5 cosine x over 2, and we want to sketch it over the interval from negative 30 to 450, labeling intercepts, maximums, minimums, principal axis, and so on and so forth. So if I go to my calculator, I've got the function already entered. My mode is in degrees. My window, I want to go from negative 30 to 450, which I am, and now I'm going to zoom to fit, which is 0. It will magically exactly fit the graph that I've chosen. And now I can see what is going on here. I can see that if I trace this, I want to make my graph. And so to help me out, I'm going to put in 0, which is my intercept. I know at 0 I get the value of 7. So 0, comma 7. My minimum value here, well, I have to figure out what the maximum is, the minimums, and so on and so forth. I do want to go from negative 30, so negative 30 I'm going to put in there, which is 6.8. So negative 30 is just a little bit here is where I want to start the graph. I'm going to find this x-intercept by calculating the 0. And I'm going to go from negative 30, sure, and then go to, I don't know, 300, let's say. I'm just guessing. And then I back up just a little bit to guess nearby. And I get 227. Yes, I get 227 is right about here. So this is 227, comma 0. And I also need to find the minimum value. So if I find the minimum, going to number 3, I can make that the left bound. I'll make 445 the right bound, and we'll back up a bit to find the minimum. And the minimum, we have to recognize that that is actually 360 degrees and at negative 3. So here is the minimum value at 360, comma negative 3. And so what I can see is that here's the maximum, here's the minimum. I know I have the intercepts taken care of. I have my maximums and minimums taken care of. The principal axis is halfway between the maximum and the minimum. So if I look at from 7 to negative 3 is a value of 10. And if I actually add them and, if I add them, so I go 7 plus negative 3, that makes 4, and I divide that by 2, that gives me my principal axis. And so my principal axis is going to be this value here at 2. And so my trig function will be on this one. Here's my maximum. And here's, I'm going to graph this out. And so this is what my graph will look like, something like that. Okay, and so this is y is equal to 2. This will be 180 degrees, I believe. But if I check that, if I type in 180, that is going to be at 2 here. And so I've got my principal axis, minimum, max, and the intercept. This is a sketch that I would have to provide labeled as such. Okay, now looking for the period of this particular function, recognize that here's a maximum, here's a minimum. The graph will keep on going. And so this here is half a period. And so if from 0 to 360 is half the period, the full period will be times 2. 2 times 360, which I know is 720. And so the period is 720. The amplitude, I know, goes from the top one to the bottom. If I subtract those values, so if I go 7 minus a negative 3, and I divide that by 2, I'll get 10 over 2, which is equal to 5. So my amplitude is 5. I can also see from here, from this value 2 up to 7 is 5, or from this value of principal axis to the minimum is also 5. And then let me do a little bit of tidying up here. It says to find the value where f of x equals 4, a graphical solution. Well, if I want that to be true, if I make a blue line here, I am looking specifically for this point here. And so if I do it graphically, I'm going to put 4 into my scenario, and I'm going to look for the intersection of those two graphs. And I get the value of 132, comma 4 to 3 significant figures. So there's the graphical solution. So x is equal to 132. And then finally, G part says f of x equals k. It has exactly 2 solutions. Determine the range of values for k. Well, if we're going to do that, if I put this line on here, let me put on this pink dotted line. I'm looking to see where does this solution touch the graph on this particular interval. So I'm going to erase some of this stuff here. Where does it touch the graph exactly 2 times? And so if I look at that, here's my graph went to here. I want exactly 2 solutions. Well, I know here there's 1 solution. Here there's 2 because it intersects. And it goes up to here at 450. There's 2 solutions all the way here. And then it goes 1 solution, 1 solution, 1 solution, 1 solution, 1 solution, and then it goes up to here again. There are 2 solutions. And so I'm looking for when there are going to be 2 solutions. Well, from the symmetry of the graph, I know from negative 30 to positive 30, it intersects twice. So k will be when this x value is here, up to but not including when it is up to 7. So the k value is less than 7, but I want to find out the value here at 30. So if I type in 30, oh, I want the other function though, 30, I get 6.82. So I know from 6.82 less than or equal to k, it will intersect the pink line exactly twice. Then it no longer does, no longer does, no longer does. Then at 450, it starts again when x is 450. So if I'm going to trace 450, I know at negative 1.54, negative 1.54, less than or equal to k, less than, and I'm going to pull this down here. So there's 2 solutions, 2 solutions, 2 solutions, 2 solutions, 1 solution, up to, but not including negative 3. And so k, when k is on this interval or on this particular interval, there are exactly 2 solutions to the equation. That's quite a more sophisticated kind of problem to work on.